Strains of gram-negative bacteria, including pathogens like E. coli and Salmonella, are rapidly evolving to resist our current library of medications. As they develop into multi-drug resistant strains, treating the infections they cause becomes increasingly difficult. The evolutionary advantage of these bacteria lies in their physical structure. They possess an outer membrane made of lipopolysaccharides, a dense layer of fats and sugars. This barrier acts like a fortress wall, physically blocking most standard antibiotics from ever entering the cell. Defeating that membrane requires expensive, highly specialized secondary line antibiotics. While wealthy nations can usually absorb those high costs, resource-limited settings are often left dangerously exposed to these resistant infections. Global public health urgently requires an alternative. Doctors need a highly accessible antimicrobial agent, biologically aggressive enough to pierce that gram-negative shield. A new study in the Journal of Contemporary Academic Research and Methodologies takes this problem head-on. Lead author Istifanus Mary Francis and a team from Nigeria set out to test if traditional medicinal plants hold up under strict laboratory scrutiny. Their core hypothesis was highly specific. Can common plant extracts generate the brute force required to break through a gram-negative bacterial shield? The researchers bypassed anecdotal surveys. They designed a head-to-head clinical trial to find a viable medical weapon. The team selected two common culinary spices known for their historical medicinal use, ginger and the highly aromatic clove. The team isolated a specific variable, the extraction method. They evaluated how these botanicals performed when processed with water versus high-grade ethanol. The choice of solvent determines exactly which molecules are pulled from the plant material. Alcohol extracts different active compounds than water, directly altering the chemical makeup and the potential lethality of the resulting mixture. When applied to the clinical isolates, ginger put up a measurable fight, but it ultimately failed to clear the bacterial colonies. This chart illustrates ginger's biological limitation. It acts as a bacteriostatic agent. It suppresses bacterial reproduction, causing the growth curve to level off, but it never drops the population to zero. Stalling a superbug buys time, but it doesn't cure a multi-drug-resistant infection. The pathogen remains alive. This bar chart shows the ethanol-extracted clove's performance. Against E. coli, it carved out a massive 26 mm zone of inhibition. For perspective, the synthetic antibiotic gentamicin cleared 29.9 mm against the same bacteria. The clove extract performed almost as well as the medical gold standard. This performance is driven by the ethanol solvent's ability to mobilize a specific molecule inside the clove, a destructive phenolic compound called eugenol. Eugenol acts exactly like a high-powered microscopic drill. It integrates directly into the bacteria's defenses, aggressively rupturing the lipid layer. Once inside, it triggers severe oxidative stress, causing the entire structural integrity of the cell to collapse. Ethanol-extracted clove bypasses the limitation of ginger. It physically obliterates the bacteria from the inside out. To prove this lethal capacity, the researchers utilized a mathematical ratio. They compared the minimum bactericidal concentration to the minimum inhibitory concentration. This equation sets the clinical standard. If an agent scores a ratio of 4 or less, it's classified as a definitive bactericidal. The ethanol clove extract scored between 0.5 and 4.0 across the tested isolates, definitively crossing the clinical threshold as a lethal bactericidal agent. This gives clinics in resource-limited settings a data-backed blueprint. A cheap, highly accessible natural resource, when properly extracted with ethanol, can be integrated into local antimicrobial stewardship programs to fight multi-drug-resistant pathogens. Mary Francis and her team in Nigeria have provided a rigorous, peer-reviewed methodology for utilizing local botanicals. You can read their complete findings in the Journal of Contemporary Academic Research and Methodologies. The solutions to our most advanced medical crises might not always require a new synthetic chemical. Sometimes it just requires applying rigorous scientific methods to nature's most accessible tools.
Submit your manuscript today.